Let's look at example from 8.1. Let's look at number 20 on page 451 if you're using the new edition, but it's number 20 out of section 8.1. It says, Gentle Ben is a Morgan horse at a Colorado dude ranch. Over the past 8 weeks, a veterinarian took the following glucose readings from the horse in milligrams per 100 milliliters. The sample mean is X bar, approximately 93.8. Let X be a random variable representing glucose readings taken from Gentle Ben. We may assume that X has a normal distribution, and we know from past experience that sigma, remember that's the population standard deviation, is 12.5. The mean glucose level for horses should be mu equals 85 milligrams per 100 milliliters. Do these data indicate that Gentle Ben has an overall average glucose level higher than 85? Use alpha equal to 0.05. So make sure you're reading the problem clearly, you're looking at what the question asks you so that you're able to identify the difference between hypothesis testing and confidence intervals like we did in the last chapter. So this is not asking for a confidence interval, it's asking a question here. And this is how we always set up our alternative hypothesis. Do the data indicate that Gentle Ben has an overall average glucose level higher than 85? So I know in my first step, I'm always going to set up a null and alternative hypothesis. We use colons here. Don't put an equals there. Okay? From the question, it had asked me, do the data indicate that Gentle Ben has an overall average glucose higher, so I'm going to have mu higher than 85. My null then is always that this population parameter, it's either going to be mu or p at this point, is equal to 85. That's my first step. My second step is the test statistic. So because this problem told us that sigma equals 12.5 from past experience, that's the population standard deviation. Okay, if it didn't tell me that, I have to use a t-test, but since it told me that, I'm going to use a z-test. Okay, so we want to go and we want to put the data in our calculator, go stat edit, and we're going to type the values that the problem gave us. You may want to hit pause and type those in. Then we go to stat, over to test, stat, over to test. On z-test, we hit enter. This time we have the data. Be careful. If the problem ever asks you to verify, like this one had said the sample mean is X bar is approximately 93.8, they have rounded it. Do not put the stats in. You want to hit data because that rounding will set your numbers off a little bit. So I'm going to hit data. My mu naught is what I'm assuming to be true in the null, which is 85. My standard deviation the problem gave us was 12.5. Again, that's the population standard deviation. My data is in L1. Frequency remains 1. Now my alternative is greater than. And remember, this is determined to be a right-tailed test. So I do greater than and calculate. So my test statistic is 1 point, and we can round this to 2 decimal places, 1.98. I'm going to skip down on my paper and just write what my calculator gave me for a p-value in step 4, and then we'll go ahead and evaluate that later. And usually we do the p-value to 4 decimal places, 0.0239. Okay? Now, step 3, we draw our critical region, and we do this based on whatever the alternative is says. We know this is a right-tailed test. Because we use a z-test, we're going to look up our z critical value. We use our table, and you'll notice where you found the critical values for confidence intervals, right beside it has a little table here. We know that alpha is 0.05, and we have a right-tailed test. So 1.645 is our critical value. Okay, so we're going to reject H null if our Z test statistic falls in the rejection. Remember, this is the rejection region. So remember, my center is still 0. So where's 1.9? Think of this as a number line. 1.9, does it fall to the left of 1.645 or to the right? Just a little bit to the right. Okay, so my test statistic is in my rejection region, which means my decision is reject H naught. Remember, we're either going to say do not reject H naught or reject H naught here. The book sometimes uses fail to reject instead of do not reject. I will always say do not reject. Okay, now we look at our p-value, and our decision should be the same. Remember, our statement here is we're going to reject H naught if our p-value is less than alpha. So our question is 0.0239 question mark less than 0.05? So decimal, if you don't remember, hopefully you all remember how to compare decimals. You would imagine the same number of zeros behind this. Think of it just as a number. Which one is smaller? This one is smaller. 239 is smaller than 500. So 0.0239 is less than. So the answer is yes. So we reject H naught. Our last step is writing our conclusion. So we say at the 5% level of significance, because that's what alpha is. Remember, this is where we say we do or do not have enough statistical evidence to prove the alternative. Since we rejected, we do. If we would have said do not reject, we would say we do not have enough statistical evidence. Here we do have enough statistical evidence to conclude that, remember that's kind of like your keyword there, and we're going to say the alternative. So we have to put it in terms of the problem, and in the problem it said, do these indicate that? See where that? And then this is what we're going to fill in. Gentle Ben has an overall average glucose level higher than 85. So to conclude that, Gentle Ben has an average glucose level higher than 85 milligrams per 100 milliliters. Okay, make sure you put that in terms of the problem. And those are the 5 steps for a Z-test.